Good evening. This is Aiswarya Venkadachalam. I will be presenting on two-dimensional stress analysis of plates bonded with flexible adhesive. Here is the brief introduction about the project. 2D plane stress analysis of the plate is studied in scope of finding shear stress distribution on top layer of adhesive. Stresses are compared for 4-node quad element and LST element. Mesh convergent is performed by H refinement method. Also, results are compared with ANSYS results. Plate configuration is shown here. As you can see, two plates are bonded together with an overlap length of 10 mm. Top plate is aluminum and bottom plate is steel. It is fixed at one end and force of 600 Newton is applied on the other end. For simplicity, adhesive is considered as relatively stiff isotropic material of definite thickness. Bond is assumed to be perfect, that is, the edge nodes of adhesive move in conjunction with plate. Mesh is generated in MATLAB using 4-node quad element. Element stiffness can be determined by the formula shown. Here h is the thickness of plate in z direction, which is assumed to be 1 mm. Overlap length is first discretized into 10 elements. Shear stress distribution along overlap length is shown. Analysis shows that shear stress of adhesive at aluminum end is high, which is a less stiff material, and it progressively decreasing to the other end. So if damage occurs, it will initiate at this point. Results are in compliance with ANSYS results with maximum error percentage of 1.47. Here, an uneven stress distribution is seen near the ends of the adhesive. This should be avoided. Therefore, mesh convergence is done to get a smoothness in solution by H refinement method. The density of element is increased along the overlap length to get a converged result by considering the stresses at the adhesive ends as variables. Graph shows the effect of mesh density. There is a significant difference in stress values between 10 and 30 elements, and the curve is much smoother afterwards. Therefore, we can assume the overlap length should have a minimum of 50 elements to get a best approximate solution. The refined mesh solution is shown here. As you can see, smoothness can be achieved. A comparative study is done with LST elements. Profile of shear distribution looks very similar to 4-node quad element except at the ends. Study is extended to find the reason by calculating strain energy and average stress values. Results are shown in the table here. Both the methods are predicting really close values from which the reason for offset in trend is hard to conclude. Conclusion here is without a datum line, it is difficult to compare two elements. Also, in order to get a more realistic solution, convergence should be done by increasing the polynomial order of shape function. Thank you.